First part, label the vertex angle, the base angles, legs, and base of each triangle below. So these are isosceles triangles because there are two sides that are equal with these tick marks. So the vertex angle is where the two sides that are congruent come together. So the vertex angle is right here. And it's an angle. Over here in the other one, where the two angles come together, the two sides come together, is a 90-degree angle. So this is the vertex angle. The base angles of an isosceles triangle are the two triangles that are congruent. So here are the base angles. And then over here, here are the base angles. And I'm marking them that they're congruent. Bate says the base angles of isosceles triangle are congruent. And then the legs are the two sides that are congruent. So this is a leg, this is a leg, this is a leg, this is a leg. And the base is where the base angles come together. So this is the base, and this is the base. Okay, using that information, this is going to be an isosceles triangle down here because the base angles are congruent. These two sides are congruent. So that means that 8y minus 16 equals 72 because these two angles are congruent. So I'm going to add 16 to each side. So 8y equals 88, y equals 11. So before I can solve for x, I need to figure out, well actually I could do, so this is 72 degrees. So I have y is 11, now I have to figure out x. So if these both are 72, the whole triangle adds up to 180. So you're going to write 72 plus 72 plus 9x equals 180. So 144 plus 9x equals 180. So 9x, subtract 180 from both sides, equals 36. X equals 4. So y equals 11 and x equals 4. The second one is, this is an isosceles triangle because both these angles are congruent, so x and y have to be equal. So in order to figure out what x and y is, I know that x plus y has to equal 180 minus 110. Oops, 180 minus 110. So 180 minus 110 is 70. So these two angles have to be 70 degrees total, and they're equal. So 70 divided by 2 is 35. So x and y equals 35. And then the last diagram is, these are equilateral triangles. All sides and all angles are congruent. This is a square right here because it has a 90-degree angle. So this has to be 90. And these two have to be 60 because equilateral degrees triangles are 60. So to figure this out, I would do that there's 360 degrees total going around here. It's a circle. So 60 plus 90 plus 60 plus t has to equal 360. So the answer is going to be 360 minus 90 minus 60 minus 60. So 360 minus 120 is 240 minus 90 is 240 minus 90 is 150. So it's 150 degrees. Alright, I wrote my givens down. So all of these are given. Now I'm going to go through and mark my givens or see what my givens give me. So if AB is perpendicular to BC, I'm going to mark that it's a 90-degree angle. So angle ABC is a right angle by definition of perpendicular. Same with the second one, ED is perpendicular to FE. So angle ED, oops, I gotta erase that. So let's see, it's gonna be angle FED is a right angle by definition of perpendicular. So since there are right angles, these have to be right triangles. So I'm going to do that on the same line. So angle ABC and angle DEF are right triangles by definition of right triangles, because right triangles have right angles. Oops, I wrote down triangles and I said angles. These are right triangles. So as soon as you have right triangles, you can look at if you can use HL. So to use HL, you have to define that they are right triangles, which we did. You have to have the hypotenuses are congruent, which they are, and it's written in my diagram too that AC is congruent to FD. And you have to prove that one leg is congruent to another leg, which I have two in my proof. So right now I can say that the triangles are congruent. I can write down that triangle ABC is congruent to triangle DEF by HL. So the sequence of HL is, when you're given two lines are perpendicular, you need to write that they're right angles. So I have right angles by definition of perpendicular. So then I write that they're right triangles. Then I can use HL because I have the hypotenuses are congruent and the legs are congruent. And for the second one, I wrote down my givens. So the first given, I'm going to use MJ is perpendicular to NK. So that means that angle MJN and angle MJK are right angles by definition of perpendicular. And then my other given is marked. Those are the hypotenuses. These two are the hypotenuse. So I can already see right now that this is going to be an HL. So I'm going to write MJ is congruent to MJ by reflexive. So before I use HL, I must write that they are right triangles. So the triangle MJN is congruent to triangle MJK. Not congruent. Oops, I messed up. So I gotta erase that. These are right. I got ahead of myself. So these are right triangles by definition of right triangles. We have to write definition of right triangles after we write that they are right angles. Now I can say that because the legs are congruent, or a leg is congruent to another leg, and the hypotenuses are congruent, and they're right triangles, that the triangles are congruent. So triangle MJN is congruent to triangle MJK by HL. Alright, so I wrote my two givens down. So AP is congruent to CB. I'm going to mark it. And wait, I need to erase this. Okay, so I wrote down the wrong given. This is AD. So AD is congruent to BC. Got that. It's already marked. And then angle D and angle B are right angles. So if I have right angles, I'm going to write that they have right triangles, because probably I'll use that with HL. So triangle ADC and triangle CBA are right triangles by definition of a right triangle. So right now I have legs are congruent, and I can write that the hypotenuse are congruent because AC is congruent to AC by reflexive. And I'm going to go mark it 2 ticks. So I wrote down already that I have right triangles, and I have that the hypotenuse are congruent and the legs are congruent. One leg is congruent to another leg, one hypotenuse is congruent to another hypotenuse. So now I can write that triangle ADC is congruent to triangle CBA by HL. And then the last one, I'm going to write my givens. Alright, I wrote down my givens and it looks like they're marked. So I'm wondering if I'm trying to prove that these 2 blue triangles are congruent. That's my goal. That's going to be my bottom line. So on those 2 blue triangles, I only have side. So I need either another angle that's in between them, or I need another side. So what I do know is that if these 2 sides are congruent, I have this big triangle, which I'm going to draw out. So we have that this side is congruent to this side. This is EAD. So then I know that triangle EAD is isosceles by definition of isosceles, because I know these 2 sides are equal. If 2 sides of a triangle are equal, congruent, then it is isosceles. So because of that, I know that angle A is congruent to angle D. So angle A is congruent to angle D. I'm going to mark it over here. That is by the base angles of an isosceles triangle are congruent. So bait. So before you can use bait, you have to write that it's an isosceles triangle. Just like before you can use HL, you have to write that it's a right triangle. So then, on my diagram, these 2 triangles are congruent by side angle side. So triangle ABE is congruent to triangle DCE by side angle side.